So this video goes over the chapter 1 review. Chapter 1 is introducing what is chemistry and the scientific method. So the first question here was asking you to classify each statement as an observation, a scientific law, or a theory. So let's go over the first statement. The atmospheric pressure has been measured in Seattle yesterday and was equal to 30.21 inches of mercury. So whenever you have a statement that has a measurement, and here the measurement is 30.21 inches of mercury, this is called an observation. This is most precisely a quantitative observation. Quantitative because there is that measurement here. So, and observations are that it's just you're looking at nature or the universe, what you have around you, and make a measurement. That's what observations are. They can be qualitative as well, and in this case you would not have a measurement, but whenever you have a measurement, that's definitely an observation, and in this case a quantitative observation because you're giving a quantity. So it's something you observed at a point in time and in a place, in a specific place. Second statement, all matter is composed of small particles called atoms. So if you have read the chapter, I think they give this as an example of a theory. This is the first theory actually, and it's called Dalton's atomic theory. That's the first theory that suggested that matter was made of small particles that we call atoms. And it's Dalton in 1808 who wrote that first version of the atomic theory. So a theory is trying to imagine what matter is made of, is trying to visualize things, explain them. And that's what it's doing here. It's trying to visualize matter as, a collection of atoms. So that's a theory. Statement C, a sample of air is analyzed and composed of roughly 80% of nitrogen and 20% of oxygen gases. So again here, hopefully now you are thinking, oh, that's another quantitative observation. Because again, we are having some measurement here, the 80% of nitrogen and 20% of oxygen gas that have been measured in being in the air, from a sample that was taken at some point in time. In some place. So that's an observation because you have measurements, even though you may think, oh, but everywhere air is supposed to be composed of 80% of nitrogen, 20% of oxygen roughly, which is true, but there is other gases in smaller quantity, so the percentages here imply that there's nothing else, but that's not true. That's the two main gases that you find in the air, but there is also carbon dioxide, water, argon, so there's many other gases in smaller quantities. Okay, so that's an observation. At some point in time you're making this measurement. Statement D, in a chemical reaction, matter is neither created nor destroyed. So this came from multiple observations that showed a pattern. And the pattern was that whenever you observed a chemical reaction, you saw that, matter was conserved. That's a law of, it's the law of conservation of matter. I know you don't know that name, but that's a scientific law. Laws are explaining patterns, what you can expect. So if you're trying to do a chemical reaction now, you would see that the mass of matter you start with will be conserved, and you will end up with the same mass once the reaction is done. And that's the law of conservation of matter, or conservation of, it's actually mass. Most of the time it's called law of conservation of mass. And if mass is conserved, then matter is conserved, right? You have the same number of atoms of one kind before the reaction, and you retrieve the same number of atoms of the same kind after the reaction. So that's the law of conservation of mass here. So question 2, give the 3 main steps of the scientific method. So chemists, as a scientist, use the scientific method, and it's when the scientific method was, thought of as the way to observe nature and try to explain it. It's when people started to use the scientific method that they made a lot of progress, because this allows you to be systematic, record all your observations. So the first step is to make observations about the world around you. So like the examples we saw above, these are observations that the atmospheric pressure has been measured and is equal to 30.21 inches of mercury, for example. So you're making observations, and then because scientists and like chemists are curious, they try to explain things. So they will formulate hypotheses, and an hypothesis is a tentative explanation of what you observe. It's trying to explain, oh, I observed this because of that, right? So the second step is to write an hypothesis, and then the last most important step in the scientific method is to perform experiments to test the hypothesis. So experiments are basically like observations, but in a controlled environment, and you're controlling the variables. Typically, when you are doing experiments, you want to change one variable at a time and control and keep all the others the same. So you need to do experiments, and then they will lead to results. And those results, because ultimately what scientists want to arrive at is laws and theories. And laws, you arrive at laws when you have done many, many experiments and you see a pattern. You see that the same thing always happens. For example, when you hold an object and you drop it, you let it fall, it always falls to the ground, right? Well, depending on the density, but it falls to the ground, and that's due to the gravity. So that's the law of gravity. So laws explain, patterns that you see over and over. So when you are able to come to a law, it's because you've seen the same behavior over and over. Theory is really the ultimate goal. It's an attempt to explain the behavior of nature by modeling nature. So it explains why things happen the way they do. So like when we are observing matter, to try to visualize how is matter at the atomic level is helpful. You can then predict things. Theories allow you to predict things and understand why atoms will behave in such way, in such conditions. So that's what scientists try to arrive at. And so I have this, let me jump to the back, to the bottom here. I have this table here that may help you differentiate between observations, hypotheses, and law and theory. If you look at the left side of the table, what describes what happens, And if it applies to a single or small number of events, that will be an observation here, right? An observation describes what you see, what happens, but it's only for one event, one thing at a time. So this would be called an observation. But if you see that you see it happening to all events of the same kind, then it becomes a law, a scientific law. And so a law still tries to describe what happens. Now, explains why things happens. That's the hypothesis when you are looking at only one event, or a smaller number of events. So you're trying to explain things by formulating an hypothesis. And then when you are able to understand more, then you're able to create a theory. And this applies to all events. So laws and theories are considered the truth, what is the closest to the truth, as long as they are not contradicted by experiments. So they can be refined with time. So for example, Dalton atomic theory has been refined over time because of the experiments that have been made and that have shown that, some part of the theory that was written in 1808 had to be rethought and rewritten. But overall, it's a good basis. It was a good basis. So yes, theories are, considered to be the truth until they are proven wrong, and then you need to refine them. You don't need to throw them away. You only need to change some parts of it, typically. Okay, so that explains question 2. So the last question is, what is the good definition of chemistry? So is it the science that deals with living organisms by studying the molecules that make up the organism? The science that seeks to understand what the universe does by studying interactions of energy with matter? The science that deals with the materials of the universe and the changes that these materials undergo? Or the science that seeks to understand the interactions of molecules for the sake of advancing human control over nature? So it's one of them. It's not none of the above. It's one of them, and it's actually answer C. Let me put that in red here to emphasize that's the answer. I see that you've were tempted to say it's actually the science that seeks to understand what the universe does by studying interactions of energy with matter. It's true that in chemistry we are studying the effect of changes in energy on matter. But really the basis for chemistry is the study of matter. You can, in the universe, there is 2 categories where you can place or classify things. Anything that you see in the universe can be classified as either matter or energy. And chemistry is the study of matter, and physics is the study of energy. But of course, matter is affected by energy, so that's why we will deal with some, energy in chemistry. But really, it's all about trying to visualize what matter is made of and what happens when you have chemical reactions happening.